Good morning, class. Today is a little bit longer than our last 2 days, and as a result, we're probably not going to do a new section on Friday. We just want to give you time to make sure that you've got um, sections 9.1 and 9.2 and 9.3 finished up. So let's start here. Today, we're going to be looking at solving equations that have two things, right? Not only do they have absolute value, but they also will have inequalities. So that's what we're shooting for by the end of the period. So to start that, let's begin here with question 25. It says, and I'll just read: absolute value is a numerical value of a number without its sign. Absolute value can represent the distance on a number line between a number and the origin 0. Using the looking inside strategy for solving equations from chapter 3, solve the absolute value of 3x minus 5 is 16. So we're not working in teams, unfortunately. So if I was to, let me go ahead and write that down. So here's the absolute value equation. The absolute value of 3x minus 5 is equal to 16. And we're going to be using this thing called the looking inside method. And the thing that I know is this thing that's inside, right? This 3x minus 5, this can be one of two things because I'm going to be taking the absolute value of 3x minus 5 and getting the number 16. So that means that that thing inside can either be negative 16, because if the 3x minus 5 was negative 16, that would give me 16 for an answer. And again, it's just what this thing inside can be. And also, this thing inside could be the number positive 16. And the reason why it could be positive 16 is because, of course, if this was 16, right, then the 3x minus 5 would be 16. So the value inside of the absolute value, the 3x minus 5, can either be 16 or it could be negative 16. So because of that, there's two equations that show up, right? One of the equations is 3x minus 5 is negative 16, or the other thing that it could be is the 3x minus 5 could be positive 16. So the thing inside, looking inside, is either a negative 16 or it's positive 16. Now, to solve these, I just solve each of them. They're straightforward linear equations, just solve them independently. But they do have the same two steps. On both of them, I'm going to be adding 5, and then I'm going to be uh, dividing by 3, right? They're both going to have this 3. But the important thing to notice is that they're starting at different spots. One starting at negative 16 and the other starting at positive 16, so we're going to get different values. Over here on the left-hand side, if I go ahead and add the 5 to both sides, I get 3x is 11. That's me adding 5 to each side of that. And if I divide then by 3, I get that 3x, or x rather, has to be negative 11 thirds. On the other side of that, right, I'm going to still add 5. And when I add 5, I get that 3x is 21. And then dividing by 3, I get that x is going to be the number 7. So there you go. Our two equations there are 3x, our two results rather, are x is either 11 thirds or x is equal to 7. So one of the things that is nice to consider and think about as we're going on is the fact that I can definitely check this answer, right? So if I was to give both of these their due, right, and plug both of these in to check, so in the first case, I'm going to have the absolute value of 3 times this negative 11 thirds, and then minus 5, and we're going to see what that becomes. And in the other case, I'm going to take this 7, and that's going to be a 3 times the 7, and then minus 5. And we're going to see what we get for both of those. So this one I like a lot. When I take this 3 and I multiply by a negative 11 thirds, this thing's just going to become the number negative 11. So we've got a negative 11 right there, and then minus 5. So what we end up getting is inside of the absolute value symbol, right, we get the absolute value of negative 16. Well, the absolute value of negative 16 is 16, so this one checks. And on the other one, no fractions, so less anxiety for most of us. 3 times 7 is 21, and then 21 minus 5 is 16. And so we're looking at the absolute value of 16, which is obviously 16. So both of those check, right? The absolute value of 3x minus 5 is 16. That equation has two solutions. Either x is negative 11 thirds or x is 7. Okay, so let's see how this goes. We're going to look at, we're going to build up slowly to where we can do two things. We can write inequalities that have absolute value, and we can solve those. So we're going to start here. Henry, hi Henry. Henry is riding his bike, and he's being very careful to cross the road if he sees kids on the other side and stay 6 feet away from everyone. But Henry is riding his bike along a straight road when his mom calls. When he gets a call rather from his mom asking where he is, Henry says that he is 7 miles from home. A. Draw a number line with integers from negative 10 to 10 representing the road Henry is traveling on. Okay, that's easy. I'll just still a number line. And place Henry's home at 0. There we go. There's no place like home. There's Henry's little home sweet home. Can I? Oh, I didn't mean to do that. There's Henry's home. Um, and then mark positions on the road, the number line, where Henry could be when his mom called. Okay, so he said he was 7 miles away. Well, if our friend Henry is away, well, he's not at 0, right? He's 7 miles away, so he could be. Oh, he could be over here, right? Because that's 7 miles away. So let's put Henry there. Henry could be right there. But that's not the only place that's 7 miles away from his home, right? Henry could also be, all the way over here, right? So Henry could be at -7 also. So there's two places where Henry could be. Henry could be at +7. Hi, Henry at +7. And Henry could be at -7. Hi, Henry at -7. And the next thing we're asked to do, it says use absolute value to write an equation given Henry's possible location. Huh. Well, let me see. I know that Henry could be at -7, right? Henry could be at -7. I also know that Henry could be at +7. So those are the two places. And he can't be at both of those, right? There's no way Henry can be both at +7 and -7. Oh my gosh, a superposition. No, he's at one or the other. This isn't the quantum world. So this is definitely an or that joins them, right? So he's either to the left, or I guess you could say to the west of his house at -7, or to the east at 7. That's probably a common convention. So here we see this situation, right? We see the thing where Henry could be at one or the other. Well, this is what gives rise to the absolute value equation, right? There are two things that x could be. X could either be 7 or -7, and this is precisely the equation that shows that. So we're gonna leave this here. Here it is. It says use absolute value to write an equation given Henry's possible. Oh, there we go. So Henry's absolute position relative to his house, is 7, and x represents what? X represents Henry's position. Okay, next, Henry continues along his route when his friend Emerson calls asking where he is. Henry says, "Hey, I am 3 miles east of my house. I'm 3 miles east of my house." "Great," says Emerson. "I'm just 2 miles away. I'll see you soon." And she hangs up. Okay. Draw a new number line marking positions or Henry's position and Emerson's possible positions. Okay, I think we could do that. So here we are, a number line again. We know Henry's house was at 0. And Henry says that, hey, I am 3 miles east of my house. That's why I just am showing the positive here. I'm in my world, I'm assuming moving to the east is positive. It would look like any map I picked up. So we put Henry right there. Hi, Henry. Hi, Henry. 3 miles east of your house. Now, Emerson's possible position. She says, "I'm 3 miles away." That's great. Hey, did she say I'm 3 miles away? No, she says I'm just 2 miles away. There we go. So this is too close. That's not where Emerson is, right? She says I'm 2 miles away. Well, that's not 2 miles away, right? The difference between Henry's location and where she is, right? That's only 1 mile away. So she could be here, right? One of the places she could be here. And I don't know that she's here, right? I'll put a question mark above her, but she could possibly be here. So this is one of the places she could be. Now I go the other way. That's only 1 mile away. That's 2 miles away from Henry, right? So she could be also here. Okay, so I'm going to put another. There she is, and with the possibility she could be there as well. So the thing that I want to say here is, look, the locations 1 and 5, right, are both 2 units away from 3. This 1 is 2 away from the 3, and this 5 is 2 away from the 3. So the two places she could be, right, are at 1 and 5, and those are both 2 units away from 3. So the difference between where she is, x. Okay, so she is at x. The difference between where she is at x, the difference between where she is, x, and where he is, 3, is 2. So I'm just going to write down a couple of things, right? So she could be at 1 or -5, and I want to try and come up with this equation. So let me say this again. I'm looking at a difference between where she is. So we're saying she's at x. So this could be the x where she's at, and this could be the x where she's at. The difference between her location, x, and his location, right, 3, is 2 units. Well, if I want to show a difference between things, right, that's subtraction. So I'm going to say the difference between um, her location and his, the difference is 2. Okay, well, and it's above or below that. So that's why I'm going to encase this with the absolute value. So this has got a subtraction right here. So the difference between her location and Henry's location is 2 units away. X minus 3, the absolute value of it, x minus 3 is 2. So this gives me, right, this opportunity now that I can think about I hope I can think about it like this. Maybe I can't. Maybe I'm fooling myself. But I'm talking about the difference between two places. Her place and his place, the difference between those is 2. And I don't know if she's to the left or the right. That's why I'm encasing this in absolute value. Because it could be that you got to go 2 negative to get to her, or you got to go 2 positive to get to her. Now, if I want to solve this absolute value inequality, what I would say is I'd say, look, the absolute value of x minus 3, the absolute value of x minus 3. Oh, I missed my absolute value is 2. The absolute value of x minus 3 is 2. So I know that I could be going 2 below or 2 above, right? So I'm going to go back to this looking inside. Looking inside, this little thing right here, this x minus 3, the x minus 3 could be -2, right? Because the absolute value of something is 2, that means that thing could be -2. And then I got the word or. I ran out of room here. I'll do the other one over here. Or the absolute value of x. Oh, no, not absolute value anymore. Or x minus 3 could be +2, right? So to the left side we'd have the negative, and to the right side we would have this +2. And to solve both of these, we're just going to add 2 to both sides. So we're just going to say, oh, that x up here, x is going to equal 1, because what did I do? I just added 3 to both sides. And over here, I'm going to say x is 5. What did I do? I just added 3 to both sides. So I I I feel like I'm not seeing your faces, and I don't feel like I'm confidently um, getting my message across. But we're going to keep trying because we're going to learn this in little bits. But I want to come back to this, the difference between where the difference, oh, see the difference, that's the subtraction problem. The difference between where she is and Henry, right? The difference is the number -2. And you could say to yourself, Mr. Roberts, couldn't I say 3 minus x? And I think you would get the absolute same answer if you put a 3 minus x in there. I feel like this is a lot more intuitive for me if I talk about, because I'm talking about her location. So the difference between her location and his location, the difference between her is 2 units away. So that's what I got to say about this one. Let's move on to our next question. Now I know what you're thinking. You're thinking, "Hey, I don't know anyone in the world that does this, right?" It's just like, dude, I'll just drop my location in this text message right here, my GPS will pick it up, and you can look on your map and you can see where I am, right? There's no thinking about this. The only reason why we're doing this, right, is we need to, I want you to know the mechanics of this notation called absolute value, right? And this is just giving me a physical situation so that we can talk about the mechanics of the absolute value. And there's a lot of systems that have two states. It's a boop over there or boop over there, and an absolute value is a good tool to use if you're not exactly sure if it's to the left above or to the right below it. So let's move on here. So now Amanda messaged Henry with the following message: I am still more than 5 miles away. Okay. Amanda messaged Henry with the following message. So so we got another person here. Amanda messaged Henry with the phone because before it was Emerson. I'm like, what do you mean you were still more than five away? What happened? You were 2 miles away, and now you're more than. No, this is a different person. Amanda messaged Henry with the following message: I am still more than 5 miles away. Henry is not sure if Amanda knows that he is not at home. Oh, she don't know because remember he's 3 miles east of his house still, right? So if Amanda thinks Henry is at home, okay, draw a number line and highlight Amanda's possible positions. Then write an absolute value inequality. Oh, an inequality, absolute value inequality to represent Amanda's possible positions on the number line. Okay, so let's do that. I'll get this out of the way. Here's my number line, here's my house. So I'm doing this if she thinks he's at home. Okay, Amanda thinks Henry's at his house at 0, and she says, I'm still more than 5 miles away. So what I'm going to do is I'm going to put an open boundary at -5. The reason why I said open boundary is that she says I'm more than 5 miles away. So if I was right at the 5, that would mean I'm at 5 miles away. But it says I'm not 5 miles away. I'm more than that. Like I'm going this way, right? I'm more than 5 away. So so this would be a possible boundary point. And the other possible boundary point that would for more than 5 away would be right here, right? More than 5 away. So if I looked at that, the points where the solutions are like over here, right? More than 5 away, not 5 away, but greater than 5 away, not 5 away, but greater than 5 away. So I'm going to have these lines, right? So this is a solution, and on the lower end, this is a possible solution. So those are my spots that are more than 5 away. So the equation, the inequality I might write would be this: the difference between Amanda and Henry, who is at home. So I'm going to show it like that. I put -0, right? So obviously this is not needed, but the difference between Amanda and Henry's at his house, the difference between Amanda and Henry is greater than 5. It's greater than 5. Oh, okay. Okay. So if I was to simplify that, that would just be written as the absolute value of x, right, is more than 5. Now, I want you to look at the two spots where there are solutions, right? One of them is over here, and this is the one where we see x's are greater than 5, right? That would be more than 5 away on the positive side. But over here, we've got this going on where we're saying that x values are less than -5. That means, oh, there's something interesting I want to note there. So let's go on to part B, and it reads, okay, so that was if Henry was at his house, if that's what she thought. But the part B says, maybe Amanda talked to Emerson. Oh, maybe those two had information. So maybe Amanda talked to Emerson and knew that Henry was 3 miles east of his house. Okay. Draw a number line and highlight Amanda's possible positions for this situation. Then write the corresponding absolute value inequality. So there's two places, right? So we know that she said that she's more than 5 away. So here's Henry, and more than 5 away would be 1, 2, 3, 4 over here, right? Here's that boundary. So let's go and mark that. So -2 is a boundary, or 5 away this direction, right, would put me a boundary at +8. So those could be her two positions. And again, we're saying that she said, "Hey, there you are, Henry. Now I think you're 3 miles east of your house. I'm more than 5 away, right?" So notice I'm using open boundaries because I'm not 5 away. She doesn't say I'm 5 or more miles away, or I'm at least. She didn't say I'm at least 5 miles away. That would be 5 or more. She says I'm more than 5 away. So it's not the 8, but it's everything right next to it going this way. So all of these values, and then also on the other side, all these values. There we go. So that's where she could be on those places. So any of these values, right, that like the 9, the 10, or the 8.5, or the -3, the -8.25, all those values, right, that are more than 5 away from Henry. So the question is, okay, so what's my absolute value inequality? Well, remember the difference between Amanda and Henry. Okay, now Henry's not at 0, right? It's not -0. Henry is now at 3 from his house. So the difference between Amanda and Henry is more than 5. Okay, it's more than 5 away. And I want you to, mm, yeah, it's more than 5 away. I'm thinking, should we solve this right now? Does it say write the corresponding absolute value? It didn't say write it, just said do this. So let's do this though. I can see my solutions, right? My solutions are two things. So if I was to solve this, oh, no, no, go back. If I was to solve that algebraically, right, I would get that x's are greater than 8 or x's are less than -2. But I think I'm anticipating what's happening next. So let's go on to C, which C is going to have me do both of these. So C says solve your inequalities in parts A and B algebraically. Do your algebraic solutions match your number lines? So let's do the A first. So on the A, we've got this, the absolute value of x minus 0 is more than 5. More than 5. So if I was to take a stab at solving this algebraically, I know looking inside, right, this thing right here could be either at -5 or it could be a +5. That expression could be one or the other. So I could say on the low side, right, I could say that the x's, right, and I've got a -5, and over here I'll do the x's, I'm going to do a +5. Now, in terms of the inequality, let's look at this carefully. Over on the left-hand side, right, its x's are all those things that are less than -5. They're the ones that are less than -5. And on the other side, it's those x's that are more than 5. They're more than 5 away. So this is kind of an instructive moment here, right? Take a look closely. That's an ugly number. Let me rewrite that. -5. So if I look at this closely, what do I have here? I've got this inequality. It flipped directions, right? Because if I want to show more, if I want to show this direction, right, more than 5 away, from the home, right? This has to be less than the -5. Because if it was more than -5, it would put me over in here, and I can't do that. So it's less than, and then the -5. All right. Now let's try this. Think through this with the other equation, the one where Henry was 3 miles east of his house. So at 3 miles east of his house, this is it, and we got to solve this thing. And if I'm just following and thinking about that pattern from the last one, right? On this side, everything seems to work, right? This x minus 3, right? And then this boundary is a 5. And I have to be more than the 5, right? Because I want to be talking about these points. So x minus 3 is more than 5. And on the lower end, I've got this x minus 3 has to be smaller than 5, right? It has to be smaller than 5. Smaller than -5, right? So I can see that I've got this absolute value is giving me these two different things, right? This thing inside is either the -5 or it's the +5. And because I want to be more than 5 away, I have to be greater than 5 on this positive end, or I have to be less than -5 on this end. less than negative 5. Now, when I solve this, right, I still have to solve it. And when I solve it, I'm going to add 3 to both sides. And on this side, I get x is less than, adding 3 to negative 5 gives me negative 2. Oh, that's what I got, right? X's are smaller than negative 2, or it's greater, or x's are greater than 8. So I'm either less than 2, any x's that are less than 2, negative 2 work, or x's greater than 8 work. Okay, so let's move on. Henry, our good friend Henry, we keep thinking about Henry. He stopped 3 miles east of his house and knows that by now Emerson must be less than 2 miles away. So there we've got his house. We've got him 3 miles east of his house. And we know that by now Emerson has to be, it says, must be, not at least, must be less than 2 miles. That's an important thing, right? I said that wrong. Must be, go back. Where's my highlighter? Must be less than 2 miles away. Okay, that's important. So I guess let's pen in where it says write and solve an absolute value inequality for Emerson. Okay. Okay, so less than 2. So something, well, let's first of all, let's say what x is, right? I'm going to say that x is Emerson's possible locations. That's what I'm going to say x is. And we're talking about the difference between Henry's location and Emerson's location, right? The difference between those things has to be less than 2. And I don't know if it's above it or below it. So that's why the absolute value comes in. So if I'm just thinking about this, the difference between Emerson's location and Henry's location. So you can see I'm showing a difference between their locations. The difference between Emerson's locations and Henry's location is less than 2. So this is different because we were doing more than before, right? I'm more than 5 away, but now by now the distance is less than 2 away. So on a number line, if I was going to just think about where that could be, let me grab this little orange color here. Let's see, less than 2. So here's 3, 4, 5. Here I'm going to put an open boundary mark at 5, and then less than 2 away, 3, go down 1, go down 2. I'm going to put an open boundary mark at the number 1. So we're saying that it's not 2 above, 2 below. It's less than 2 above. So that's why I use an open boundary, and I'm saying that Emerson's location can be anything that I just highlighted in orange here, right? Except for the endpoints. Now, if I was going to solve that absolute value in equation, right, I just presented that, and I don't even really have, I'm saying, I don't even have the picture, I'm just going to solve it. The mechanics for me look like this. Look, the x minus 3 has to be less than the number 2. That's for sure on the upper side, right? It has to be less than, it has to be coming in less than the 2, that direction with an open boundary. On the other side of that, right, the x minus 3, it's not going to be less than 2 because it has to come in. It has to come into this range. It has to go this way. So I'm going to say the x minus 3 has to be more than negative 2 on the other side, right? So try and look at the difference between these. This one right here, it was x minus 3 less than 2, x minus 3 less than 2, right? On the other side, I've got x minus 3 has to be more than negative 2. More than, and then instead of 2, it became negative 2. The x minus 3, the difference, has to be more than negative 2. So on the negative side, it can't be less than negative 2. That would push me way, way over here. It has to be more than the negative 2. Now, to solve each of these, super simple, right? All I do is I add 5. So I get that x has to be greater than, just add 3 to negative 2, and I get 1. Okay, and then on the other side, I got x has to be less than, add 3 to both sides, and I get the 5. Now, this is not an or statement, right? These two things both have to be true. Because if I said less than 5 only, that would be everything on the number line to the left of 5. And if I said greater than 1 or greater than 1, that would be everything above the 1. So this is a spot where I have to use the word and, A and D. Both of these conditions have to be true. X has to be greater than 1 and it has to be less than 5. Now, when you have an and statement like that, you can combine this into one inequality. You can say, look, here's my X, and my X's have to be smaller than 5, right? And, whoops, what? It's not letting me write my 1 right there. Come on, there we go. So there we go. So this is saying essentially that my X values have to be between 1 and 5, not including the endpoints, not including the boundary points. All right, so let's wrap this up. We're now at 30 minutes, so definitely need to finish within the next 5. So we're going to end with question 31, and this is kind of a good overall summary slash example of what we've been talking about all day today. I really encourage you guys to, if this was like, what? You watch this twice, that first half twice, this will start to make sense to you. You'll be shocked at how this, oh, less than? Oh, it's more, that's closer, it's coming within or out. But we're going to work on it more in our next lesson too, in 9.2. But right now, let's just wrap up with these 4 examples. So it says solve the inequalities below if possible and represent your solution on a number line. So let's start with A, which is right here. I'll put A by itself. There we go. So this says that the absolute value of x plus 2 is more than, it's greater than 1. So I'm thinking just based on this, right? It's like this is going to be a situation where something, right, is more than something, right? It's greater than something. So I'm going to have the thing where it's going off this direction and off this direction, right? So the thing I'm looking for is more than 1 away. It's not 1 away, and it's not less than 1 away. It's more than. So it's going to be shooting opposite directions, either above or below. So I don't have a problem with the positive part, right? That's just going to be, oh, x plus 2 has to be greater than 1. That would be this side right here where it's going off above it. It has to be greater than 1. But on the other side, right, if I was going to go this direction with that negative 1, right, then I've got x plus 2 has to be less than the negative 1. And that really that's the thing right there. That move is the move, right? And I can look at this and I can understand why it has to be less than, because it's this point but not that point. It doesn't include that point, but smaller than that point. So it's going this way. So all right, and then to solve it, I just take away 2 from both sides. So this says, oh, x has to be less than negative 3. Okay, x has to be less than negative 3. And over here, I'm going to say x has to be more than, x has to be less than 3. If I take away 2 from that, x has to be more than negative 1. Okay, so it has to be, my x values that work for that will be less than negative 3 and more than negative 1. And if I was to think about that on a number line, here is the number 0. Here's negative 1, negative 2, negative 3. And I have to be less than negative 3, so that's this direction, less than negative 3, or greater than negative 1. So not that point, but greater than negative 1. So if I pick any x value over here or any x value over here, this will work because those points are more than. These points right here, no good. None of those are going to work because none of those are more than 1 away from this thing that we were talking about, right? The difference or the sum of x and 2. So, and you know, I know that 0 is going to work. If I put 0 in there, yeah, the absolute value of 2 is greater than 1. And negative 4 should work. If I put negative 4 in there, that's going to become negative 4 plus 2 is negative 2. Absolute value of negative 2 is 2. 2 is greater than 1, right? That works. But something in here, like this is the one right in the middle of them, right? Negative 2 is not going to work. If I put negative 2 in there, I get negative 2 plus 2 is 0. 0 is not greater than 1. So this is what my solution is. And it's an and solution, right? It's an and that joins these together. And in our textbook, they may write it like this. No, and it's not an and statement, Mr. Roberts. It's great. It's greater. You'll hear me say that a lot just to remind myself. No, it's moving away. It's either here or it's here. It's not an and statement. The and statement ones, the ones in the middle, don't work. All right, let's look at B. B. Oh, okay, okay. I'm going to distribute this 2 first inside. So I'm going to rewrite this as the absolute value of 2x minus 2. The absolute value of 2x minus 2 is more than 0. What? This seems a little weird. Let's see. 2x minus 2 is more than 0. Okay. Huh. It's more than or equal to 0. More than or equal to 0. Well, on the positive end, right? If I think about this being the positive 0, I could write this. I could say 2x minus 2 is greater than or equal to 0, and it's greater. And on the other side, I'm going to say this is funky looking. 2x minus 2, let me see, is less than or equal to negative 0. There's no such thing as negative. Let me solve both of these. So if I solve it, because that's just 0, right? That's 2x is less than or equal to 2. X is less than or equal to 1. And over here, I've got 2x is uh, greater than or equal to 2. X is greater than or equal to 1. The only thing that's going to work here is 1, right? My value has to be less than or equal to 1 or greater than or equal to 1. Or, right? Both can't be true. So guess what? X is 1 is the only number that would work, right? And if I put 1 in there, oh yeah. Because, let's see. Oh, wait a minute. Wait a minute. Would anything work? Maybe any number. Maybe I've got this wrong. So see, let's look at the number line. So what I'm saying, if I was to graph this, here's the number 0, here's the number positive 1, and my boundary is it's a filled-in boundary, right? It's solid because it's or equal to, and this says that x's are less. This says x's are less than or equal to 1, so that's this direction, or x's are greater than or equal to 1, so it's this direction. Oh, any number works, right? This is all real numbers. Because if I put 0 in there, let's see, if I put 0 in for x, that's going to become absolute value of negative 2, which is the absolute value of negative 2, which is 2. 2 is greater than or equal to 0. Yeah. Oh, this right here is all reals work, all real numbers. All right. Well, I'm glad you know what? That's kind of a good reason to look at different representations because I was looking at just this, and in my mind, I could not get past I don't know, to me, it was just like, oh, so it's 1. But then I looked at the graph representation, I realized, no, anything works. Anything is possible there. All right, let's look at C. Oh, C is no absolute value. That's cool. So on C, let's see, I'm going to just add x to both sides. So that's going to give me 8x minus 4 has to be less than or equal to 6. So 8x has to be less than or equal to 10. I added 4 to both sides. So x has to be less than or equal to 10 over 8, which is what? 5/4. So any x value less than or equal to 5/4 works. In a previous lesson and on some of my homework things, I've been talking about um, I'm not using the textbook's recommendation. Well, I did when I was thinking about it at first, but the recommendation of finding the boundary point and then testing above or below it. My boundary point is 5/4, and if I was to test it, the ones that are smaller than 5/4 would be the side that work. Remember, the one thing is funky is if you're doing these the way that I just did this. Remember, if you were to multiply by any negative number or divide by a negative number, divide both sides by a negative number, right? The direction of the inequality has to switch, not because of magic, but because of reason. Like if I said, hey, 5 is less than 10, that's true. If I multiply both sides by negative 2, this becomes negative 10, this becomes negative 20. Which one's bigger now? Oh, this one's the bigger one, right? So be aware of that, right? So if I'm thinking that I'm going to multiply by negative 2, this inequality has to switch directions. Not because it's just some rule. It's because like look at it, right? And think about two numbers and what happens if you take an inequality that's true and either multiply or divide both sides by a negative number. What happens? What happens is this direction has to switch. That's when you multiply or you divide by the negative. And then our last problem I want to look at is this one. It says, oh, the absolute value of something is less than negative 2. Now, that is a problem that I could just jump right into and do all the tools and steps. And at the end, I'm going to get a contradictory statement. I'm going to get something that does not make a lot of sense. And I just want you to think about this. You know something about absolute values, right? If you put anything into, I don't care what it is, you pick your favorite value, you put anything, even that question mark, anything into the absolute value, it's always going to become a positive number, right? Because it's distance from zero. So this is saying the absolute value of something, right, is less than negative 2. Well, here's 0, 1. How's that possible, right? How can an absolute value be smaller than a negative number? It's not possible, right? There's just no way this can happen because the absolute values are going to start here. They're going to be, it could be 0, but 0 or bigger than 0. So this one right here, there's no solution. All right, that's it, guys. We're at 40 minutes. That's why we're not going to be meeting tomorrow online. So go ahead and finish up 9-1, 9-2, 9-3. Get in the participation quizzes. Make sure you turn those in, and make sure you upload your completed homework images. And I will see you on Monday.